Something strange is happening on Jupiter. The more we learn about the largest planet in our solar system, the stranger it becomes. But, in some ways, Jupiter is more familiar than you might think. Did you know that Jupiter has water, rain, and even a giant ocean? The story of this planet could leave you questioning everything. The first big event that Jupiter triggered in the early days of the solar system was its almost catastrophic impact on Earth. As the first planets began forming, Jupiter quickly gained mass, circling around the giant disk of gas and dust that surrounded our infant Sunday. As it grew larger and heavier, it was pulled inward toward the sun, spiraling toward the center and leaving a trail of nothingness in its wake. Jupiter's powerful gravity hurled asteroids in all directions. Some were exiled to interstellar space, others launched straight into the sun, while some were flung towards the developing Earth. Imagine Jupiter as a massive space Roomba, sweeping through the chaotic mix of rock, dust, and gas that was the early solar system, disrupting everything in its path. This halted the formation of new planets, and Jupiter even came close enough to Mars to permanently stun its growth. Had Jupiter come any closer, Earth's formation might have been disrupted too. But, in an incredible twist, another giant came to our rescue. The formation of Saturn changed Jupiter's path. As Jupiter moved inward, Saturn followed, and a gravitational battle began between these two massive titans. Their immense forces started to push and pull each other, accelerating them around the sun and causing them to spiral back outward to the solar system's edges. This left just enough material behind to form the inner planets, including Earth, as we know them today. In school, you probably learned that Jupiter is a giant, dense ball of gas with a small rocky core at the center. For a long time, scientists thought the same, but newer findings tell a different story. Jupiter's outer shell is composed of thick clouds filled with ammonia and water, floating in an atmosphere of hydrogen and helium. Water vapor was first detected in 1995 by the Galileo spacecraft, comprising about 0.25% of Jupiter's atmosphere. That may sound small, but it represents a volume of water millions of times greater than Earth's. Interestingly, water mainly resides in the outer solar system and doesn't originate in our neighborhood. Jupiter's gravity helped migrate water inward, slinging chunks of ice toward Earth. In Jupiter's clouds, where temperatures fall below -100 degrees Celsius, water ice crystals interact with ammonia, which acts as a natural antifreeze, allowing liquid water to exist in the upper cloud layers. Colliding water droplets and ice crystals electrify the clouds, triggering enormous lightning storms that rage across Jupiter's atmosphere. This unique water-ammonia mixture forms slushy hailstones, which fall deeper into the atmosphere, melt into rain, evaporate, and rise to repeat the process. Hot gas jets rising from Jupiter's depths fuel these storms, reaching as far down as the Great Red Spot. This famous storm, spanning thousands of kilometers in diameter and hundreds of kilometers deep, towers over the planet's other clouds, extending high enough to absorb more UV light from the sun. This interaction with atmospheric compounds creates its iconic deep red color. Imagine a storm cloud 10 times taller than Mount Everest and 10 times deeper than the ocean, still not enough to capture the scale of the red spot. As we descend below the clouds into Jupiter's lower atmosphere, temperatures rise due to increased atmospheric pressure created by the planet's intense gravity. Traveling deeper into Jupiter is like moving through a thickening fog until it transitions to a liquid state. This environment is so extreme that only hydrogen and helium can remain. Below the gas layers lies a vast ocean of liquid hydrogen, the largest in the solar system, hidden beneath Jupiter's clouds. While Jupiter may appear to be a gas giant, it's actually a liquid planet. However, this is a liquid unlike anything on Earth. Here, hydrogen can be liquefied by cooling, but on Jupiter, immense pressure raises its boiling point so it remains liquid at temperatures well over 1,000 degrees Celsius. The liquid hydrogen ocean extends about 20,000 kilometers deep, around 2,000 times the depth of Earth's ocean. At the bottom of this layer, under immense pressure and temperatures reaching 10,000 degrees Celsius, hydrogen transitions to a state known as metallic hydrogen. Metallic hydrogen, though still a liquid, has properties similar to metals, particularly in its conductivity. Jupiter's gravity compresses hydrogen to such an extent that electrons break free, flowing freely and creating an electric current. This liquid metallic hydrogen forms the majority of Jupiter's interior, stretching about 40,000 kilometers deep. Below lies Jupiter's solid core, though even this is debated. For years, scientists believed a dense, Earth-sized core made of rock and iron resided in the center of Jupiter. But recent research suggests that Jupiter's core may be fuzzy, with a gradual transition between the liquid metal and solid core, blurring the boundary between the two. We're unsure if this is unique to Jupiter or if other gas giants like Saturn share similar traits. One theory suggests that a colossal collision early in Jupiter's formation could explain its fuzzy core. This impact might have involved a rocky planet 10 times Earth's size, diluting Jupiter's core and perhaps aiding its rapid growth. If the process of compressing and heating hydrogen sounds familiar, it's because stars form in a similar way. Gravity compresses hydrogen atoms until they fuse, generating nuclear energy that ignites a star. Jupiter, though, is simply not massive enough for fusion to occur. It would need to be 75 times heavier to initiate nuclear fusion. Still, the immense energy generated in its core, combined with its rotation, creates an incredibly strong magnetic field. Jupiter's magnetosphere is 20 times stronger than Earth's and 20,000 times larger, extending so far that its 4 largest moons orbit within it. This magnetic field contributes to another odd feature, the Great Blue Spot. Although it's not actually blue, this magnetic anomaly demonstrates just how strange Jupiter's magnetic field is. Unlike Earth's magnetic field, which originates at the poles, Jupiter's originates from a broad area in its northern hemisphere, slightly offset from the pole. A massive aurora often appears above this region. Jupiter's magnetic field lines re-enter the planet at both poles, though occasionally they re-enter through the Great Blue Spot near the equator, effectively creating a second south pole. The Great Blue Spot is located at the same latitude as the Great Red Spot, hinting at unusual activity along Jupiter's equator. The planet's shape is slightly elongated around the middle, and its magnetic field lines have an irregular, asymmetrical shape, unlike the tidy lines around Earth. A few theories attempt to explain why Jupiter's magnetic field behaves this way or what forces in the solar system might be influencing its magnetism. However, the full mystery of Jupiter's magnetic field and its interactions with the solar system remains a topic for future exploration.